Okay, recording in progress. Okay, so I'm going to do some more of the polar graphs to 10.3. Okay, so we're just about right on schedule. So tomorrow, start 10.4, maybe sneak a little bit in today, but I don't have to. 2 days for 10.4, 2 days for 10.5, one buffer day, and exam next Friday. Okay, so we're doing more of these polar graphs. Reminder, you can get these polar graphs on the Canvas announcements that I sent you on Monday. You can find it on mathbits.com, but just look back at the URL that I sent you on Monday's Canvas announcements. And again, you must use exactly this graph paper for full credit. If you decide to use some other graph paper, I may not accept it at all, or I might give you reduced credit. Okay, so you can figure out, based on knowing that these are 15-degree marks and there's 14 circles, how do you analyze that? So if you use other graph paper, you lose that analysis. So I want you to be able to figure things out from that. Okay. So a couple more that I want to go over today, important concepts. So I showed you a bunch yesterday of polar graphs. Now I'm going to do for you number 41. A couple extra themes that we have to worry about here. Okay, 41, r squared equals 9 sine of 2 theta. Okay, so first thing I notice is an r squared. Second thing I notice is a 2 theta. So remember I showed you a 3 theta. A 3 theta means your table is 3 times as long. If there's a 2 theta, it has to be twice as long. Okay, and I'll just give you a heads up. There's only one problem in the homework like this. Problem 37 has a 4 theta. 4 theta means your table is 4 times as long. That can get long. Okay, but you have to try at least one on the homework. Okay, now that is so long, I would never ask a question like 37 on the test where you only have 50 minutes. However, since for a quiz you have more than half a day, I'm willing to give you something like 37 on the quiz. In fact, I'm going to go ahead and tell you right away, part of tomorrow's quiz, you're going to have to do a 4 theta. Okay, it's long, okay, but if you think of how we did the 3 theta, I'll show you how to do 2 theta, and if I have time left over, I'll give you some heads up as to do the 4 theta. Okay, so I'll give you a variation of 37 on the quiz. And by the way, that's not the only question. I might ask you another question. It's long. Again, it's the kind of thing that's a nice thing about having the quiz where you have more than half a day. It's so long, I would not give it to you on a 1-hour test, but I'm willing to give it to you for a quiz where you have more than half a day to work it out. Okay, so heads up, I am going to give you a variation of 37 tomorrow for the quiz, where you have a 4 theta involved. But for this one, we have a 2 theta. All right, so first thing I notice is what's the maximum value of r? Okay, well, I know sine of 2 theta can be as big as 1. So if r squared is 9, r has a maximum value of 3. Okay, so r equals 3 is the maximum. I have 14 circles. I will use 15 circles. Now you might say, well, they don't give me 15 circles. That's correct. Well, you have a choice. You can either draw the 15th circle. So I kind of marked off where the 15th would be and go all the way around, but usually you don't need that. Okay, or you just kind of fake it. You pretend, go out one more of these branches. Okay, so I say this is 14. Okay, this is 15. Okay, so again, I marked off that's supposed to be the 15th circle, 15th circle, 15th circle, 15th circle. One option is to go ahead and literally draw it, but you don't have to because most of the time you won't need it. In fact, in this particular graph, you only need to go out to the 15th circle, it looks like twice. Okay, so usually I would say don't bother drawing the 15th circle, just kind of pretend, fake it that you go out to the 15th circle. Okay, so I want you to be able to think of that analysis. So again, 3 is maximum r. They only give me 14 circles, go out to the 15th circle. So I want you to think of that analysis, which is one of the reasons why I insist you use exactly this graph paper. For some reason, they only gave us 14 circles, but you can pretend there's a 15th circle. And you can see, it'd be kind of tough for me to make that 15th circle, but I don't have to go out to the 15th circle that much. In this particular graph, I only have to go there and there. So I said, okay, it's not really worth it to do whatever I had to do. Okay, so r equals 3 is 15th circle. R equals 1 is the 5th circle. And therefore, any one circle is 0.2. So I'll be counting out 0.2 for each of these. Now, remember the 3 theta? Instead of going every 45 degrees, I have to go every 15 degrees. 2 theta, well, instead of going every 45 degrees, I go every 22.5 degrees, or pi over 8. Okay, so my table is going to be twice as large. I'll be counting every pi over 8. And I need to mark those off on my graph. Okay, so the game you have to play is, here's 45 degrees, here's 0 degrees. Okay, on my graph paper, they give me 1, 2, 3 marks, right? 15, 30, 45 degrees. I need to go halfway. So halfway between 3 is 1.5, right? So I have to draw a line segment like so, halfway between these two. And that would be my 22.5 or pi over 8. Okay, and then let's see. Here's pi over 2, 90 degrees. Here's pi over 4. Once again, there's 1, 2, 3 marks. So I go 1.5 and draw that line. And same thing here, halfway between pi over 2 and 3 pi over 4. 1, 2, 3. So here's 1.5 way through, draw that one. Then halfway between 3 pi over 4 and pi. So 1, 2, 3 of these marks. I go 1.5, so there's 7 pi over 8. And you keep going all the way around. And in reality, you can extend all the way across. So in other words, see right here, when you go pi over 8, you can just use your ruler to go all the way across. You're going to have to go all the way across anyway. So draw all the way across, so you automatically get that one. Okay? And by the time you draw, let's say that one, just continue, have your ruler going all the way across to get this one, and so on. Okay, so each of these, sorry, 0, 1, 2, 3, 45 degrees, cut that in half. So you go 1.5. Okay, and between 45 and 90, 1.5. And between 90 and 135, 1.5. And between 3 pi over 4 and pi, 1.5. And if you draw the line all the way across, it should match, but let's double check. Between pi and 5 pi over 4, 1, 2, 3, there's 1.5. Between 5 pi over 4 and 3 pi over 2, 1, 2, 3, so there's roughly 1.5. And between 3 pi over 2 and 7 pi over 4, 1, 2, 3, there's 1.5. And then from 7 pi over 4 to 2 pi, 1, 2, 3, there's 1.5. Okay, each of these is pi over 8. Okay, so pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5, 6, 7, 8 pi over 8, 9, 10, 11, 12 pi over 8, 13 pi over 8, 14, 15, and 16 pi over 8. Okay. And the period of this trig function is now 2 pi divided by 2, which is pi. So I get one complete period after pi. So I make my table like so, 0, and count by pi over 8, pi over 8, 2 pi over 8, 3 pi over 8, 4, 5, 6, 7, 8 pi over 8, and reduce as necessary, like 8 pi over 8 is pi, and keep going, 9 pi over 8, 10 pi over 8, 11, 12, 13, 14, 15, 16 pi over 8. Okay. Right, now, this is a little bit different. Here they have r squared. My table is going to go r squared theta. Okay. If you first think of r squared and theta, I'll fill out the table for r squared. Once I have r squared, I just take the square root to get r. Okay. Likewise here, r squared versus theta, and then do a square root after that. Okay. All right, so we'll divide and conquer again. I plug in 0. Sine of 0 is 0, so r is 0. R squared is 0. And likewise at pi. Divide and conquer, cut in half, plug in pi over 2. I plug in pi over 2, I'm taking the sine of pi, which is also 0. So that means r squared is 0. Cut those in half, here and here. Plug in pi over 4. Plug in pi over 4, I'm taking the sine of 2 pi over 4, which is pi over 2. Sine of pi over 2 is 1. 1 times 9 is 9. R squared is 9 means, well, r squared is 9. It's going to mean r is plus or minus 3. And divide and conquer again. 3 pi over 4. If I plug in 3 pi over 4, I'm taking the sine of 3 pi over 2, which is negative 1. Negative 1 times 9 is negative 9. And then this one, this one, this one, this one, all the angles in between. So pi over 8 times 2 is pi over 4. Sine of pi over 4 is radical 2 over 2. So I have 9 radical 2 over 2. You can punch in your calculator. It's basically 6.4. Okay. So again, I'm just going to be punching in a bunch of 6.4 or negative 6.4. We're going to show that through a calculator. 9 square root of 2 divided by 2. 9 radical 2 over 2, 6.36. Oh, it's 6.4. So now I'm either going to write 6.4 or negative 6.4. Okay, so right here I see a 0 and a 9, 6.4. I've got a 9 and a 0, 6.4. I have a 0 and a negative 9, negative 6.4. Negative 9 and a 0, negative 6.4. This is one period. So since I have one period, I can copy and paste. So ignore that first 0, but now just copy 6.4, 9, 6.4, 0, negative 6.4, negative 9, negative 6.4, 0. Okay. By doing this, conquer and divide, and take the two extremes, cut that in half, cut those in half, cut those in half, you can save a lot of work. Okay, so this is r squared. Now for r above it. Square root of 0, 0. It's going to be 0. 9 plus or minus 3. Any r squared which is negative, undefined. R squared equals negative 6.4, negative 9, impossible. So blank, blank, blank. It's not in my domain. That's okay. You don't have to have every number in the domain. Just like in normal x and y, you don't have the entire, all real numbers as possible. So likewise, there are some r's where there's no graph. Okay, so 0 plus or minus square root of 6.4 is about 2.5. So plus or minus 2.5, plus or minus 3, plus or minus 2.5, 0. The graph sleeps, 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 and then 0. And copy here. Plus or minus 2.5, plus or minus 3, plus or minus 2.5, 0, blank, 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 0. And then we're ready for the graph. And here, because I have a plus or minus, I have to go positive and negative. So here's the way it goes. Starts at the pole. So what's the pole? P-O-L-E is the origin. Okay, then by the time I reach to pi over 8, plus or minus 2.5. So right here and right here, 2.5, 1, 2.5, and another point here. So the graph kind of goes like this at the same time. And then pi over 4, 45 degrees, plus or minus 3. Here's positive 3, the 15th circle. And here's negative 3. So I reached the r of 3, which is my 15th circle, out to here. So the graph progresses like so, and then it goes like that. And then it's going to keep going like that and come back into the pole because 3 pi over 8 plus or minus 2.5. So 3 pi over 8, here's 2.5, here's negative 2.5. And then by the time it reaches pi over 2, 90 degrees, comes back into the pole. Right here, just a little bit smaller. Yeah, here we go. So we have this now. And then the graph sleeps, so to speak. So there's nothing, no graph here, 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 okay? Because at these angles, 5 pi over 8, 3 pi over 4, 7, there's no graph because undefined. And then the graph wakes back up, so to speak, by the time I reach here. Trying to get this focused here. Here we go. Okay, so the graph wakes up at 9 pi over 8, plus or minus 2.5. I already got it. So nothing new under the sun. I've got the same graph, and we've seen that theme before. It's just going to retrace itself. 5 pi over 4 plus or minus 3. We already got that. 11 pi over 8 plus or minus 2.5. So positive 2.5, negative 2.5. It comes back into the pole. And then again, sleep, 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 and then it wakes back up after one full revolution. So this is the entire graph. Figure 8, so to speak. Right? Okay, so I wanted to show you this to see what you do if the maximum R is 3. The maximum R is 3, go out to this 15th circle, make up a 15th circle. You don't actually have to draw it usually because it only touches at a couple points. But even if you have a lot of points, then it's really not worth it to go out there. You just aim for the next circle, so to speak. And for 2 theta, you have to cut this in half. Okay. Heads up again for problem number 37. There's a 4 theta. And I'm going to give you a heads up. Quiz tomorrow will also have a 4 theta, which means you have to cut each of these in half. So here's 22.5. You got to cut that in half. So you need 11.25 degrees. And you need to cut that in half. And all the way around the circle. So in some sense, you know what to do. In fact, since I'm already giving you a heads up what's going to be on the quiz, you can take one of these pieces of polar graph paper and start doing that even today, not leave it up to tomorrow. So I guess you could say the quiz is starting. So take one of these polar graph papers, cut it in half like I did here, and then cut each of these angles in half all the way around. So you have to go something like that, and like that, and like that, and like that, all the way around. Okay, and if I have time, I'll get you started on something like that. Okay, so that's 41. Next one I'm doing is 39 star. It was in the previous edition. So we have 1 plus 3 cosine theta for R39. This was the previous edition, but I want to show it to you because it shows you something important also here, and we'll need that later. R equals 1 minus 2 sine theta. So this is 39 star. This is not our actual 39, but your actual 39 is 1 plus 3 cosine theta. It's pretty close. Okay, once again, the maximum R is 3. Sine theta is between -1 and 1. So if this is -1 times -2 is 2 plus 1 is 3. So same thing, 15 circles. Okay, I'm not actually drawing the 15th circle because it looks like you only have to go out there once. So again, in my opinion, it's not really worth it to draw the whole circle. Just aim for what would be the 15th circle. Okay, so once again, R equals 1 is the 5th circle, and R equals 0.2 is any one circle. Okay, there's no multiple angle. There's no 2 theta or 3 theta or 4 theta. 3 theta was actually nice because here's 45 degrees. Divide that by 3, it's 15 degrees. They already give me every 15-degree marker, right? So remember the one that I did the other day that had 3 theta? This was perfect because it was already cut into 3. But if you have to cut it into 2, you got to draw the lines. And if you have to cut it into 4, that's even more work, which is what you're going to have to do for the quiz for tomorrow. Okay, so I can just do the usual every 45 degrees. So 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8 pi over 4. Okay. Again, in my opinion, it's too slow to go one by one. You should go faster. Okay, and a quick heads up, you should do shortcuts like this. So some of you are saying things like maybe you didn't have enough time to do an exam. Well, if you learn the shortcuts, it's much faster than if you trying to faithfully go one by one, do that, do that, do that, do that. That's part of the game, knowing how to do something quickly by doing the 2 extremes, cut that in half, and so on. So just keep cutting in half. Okay, so I know 0 and 2 pi give you the same answer. Sine of 0 is 0, so 1, that's a 1, that's a 1. Cut that in half. What's half between 0 and 2 pi? Pi. Plug in pi, sine of pi is also 0, that's also 1. Now cut that in half between 0 and pi over 2. Sine of pi over 2 is 1. 1 minus 2 is negative 1. Then cut this in half, go halfway. You just keep going halfway. 3 pi over 2. Sine of 3 pi over 2 is negative 1 times negative 2 is 2 plus 1 is 3. So that's 3. That's my maximum. Okay. And then I have the angles which have a reference angle of 45 degrees. That one, that one, that one, and that one. Okay. So let's see. Pi over 4. Sine of pi over 4, radical 2 over 2. Times 2 is radical 2, which is about 1.4. So 1 minus 1.4 is negative 0.4. So 1, negative 0.4, negative 1. Go back to 1, so negative 0.4, 1. Okay, now 5 pi over 4. Sine of 5 pi over 4 is negative radical 2 over 2. I'll get a double negative. So it's going to be 1 plus radical 2, 1 plus 1.4, 2.4. So 1, 2.4, 3, 2.4, 1. Okay, I'm ready to graph, but here's an instance where I don't see 0 on the graph anymore. Now I know there's going to be a 0 because you have to pass from 1 to negative 0.4 in a continuous fashion. So there's got to be a 0 somewhere. So here's a case where it is worth it to stop and figure out where does it come into the pole. Pole meaning r is 0. So I set r to 0. 1 minus 2 sine theta is 0. A little bit of algebra, sine of theta is a half. So for my unit circle, I want the y corner to be a half. That's up here. That's 30 degrees or pi over 6, and 150 degrees, which is 5 pi over 6. Okay. You might recall all students take calculus. Okay, if you haven't heard of that, A stands for all. All 3 trig functions, sine, cosine, and tangent, are positive. Here, sine is positive, tangent positive, cosine positive, which means the others are negative. All right, so I have to keep in mind when I come to 30 degrees, I come into the pole, and also 150 degrees. Okay, so here we go. At theta equals 0, r is 1. Okay, so here's 5 circles. Is 1, 1, 2, this is 0.2, 0.4, 0.6, 0.1, 1.2, 1.4, 2, 2.2, 2.4, 2.6, 2.8, and 3. Okay, so at 0 radians, I'm at 1. Now, by the time I reach pi over 4, 45 degrees, I'm at negative 0.4, which means if I aim at 45 degrees, I go back 2 circles. So I need to know when do I come into the pole? When do I reach the origin? That happens at pi over 6. We did this analysis over here. So at 30 degrees, it comes into the pole, and then it walk backwards at 45 degrees to the second circle out, because I know that r equals 0.2 is 1 circle. So negative 0.4 will be the second circle. Okay, then I continue. Pi over 2, 90 degrees, negative 1. So I'm aiming up, but I walk backwards here. Okay, and then keep going. 3 pi over 4, negative 0.4. So 3 pi over 4 is here. I walk back 2 circles, draw that dot. I come back into the pole at 5 pi over 6. So at 5 pi over 6, I come back to the origin pole, and then I come back out over here, because that gives me theta is pi, r is 1. So at 180 degrees, I'm out here. And then the rest of the graph is pretty straightforward. 5 pi over 4, 2.4. Okay. By the way, I think it's worth it. Every whole number like r equals 1, r equals 2, it's nice to make it a little bit bolder so you have a frame of reference. So that's where you're headed. So I got to go up to 2.4, right? So I know, okay, that's 1, that's 2, 0.2, 0.4. So there's 5 pi over 4. Based on this scheme here. Okay, 3 pi over 2, I'm at 3, that's the 15th circle. So that's just a little bit past the 14th circle. And in this case, that's the only such point. So again, see, I don't think it's worth it to draw that 15th circle. When you need it, just put it there. And that's all we need to do there. Okay, then 7 pi over 4, back to 2.4, 1, 2, and then 2 more circles. It's there. And then I come back into where I started from at 2 pi. And so there's my graph. So here's a situation where I have an inner loop and an outer loop. And notice for these nice graphs, we never saw anything like that in rectangular coordinates, right? X and Y, we never see nice shapes. In polar coordinates, you open up a whole new world of shapes that you can have, as you can see here. This theme will come up a little bit later. So even though this was not in our original text, it was from the old edition, but this theme of inner loop and outer loop will come up again, maybe even tomorrow or maybe Monday. But we have to talk about an inner loop and an outer loop. Okay. All right, so that's it for those graphs. And now let me knock off the last problems, 55 through 63. I'll just put a mark here, 55 to 63. Find the slope of the tangent line to the given polar curve at the point specified by the value of theta. Okay, and then 61 to 63, find the points on the given curve where the tangent is horizontal or vertical. So let's see what happens there. So I have to use this formula, dy dx. Put this on your cheat sheet. dr d theta sine theta plus r cosine theta divided by dr d theta cosine theta minus r sine theta. You want to see where it is in the text. Page 663, number 3. That's the one I mentioned the other day. Well, the last time I taught this course, we were face to face. I put don't memorize. Well, you guys literally don't have to memorize anything if you just want to put something on the cheat sheet. Anyway, it'll ask horizontal tangent. Horizontal tangent means the numerator is 0, slope is 0. Vertical tangent, for vertical line, slope is undefined. That means you're dividing by 0. So dx d theta is 0. And I hasten to add, that's provided the other isn't 0. You actually could have a case of top and bottom being 0. You still might have a horizontal or vertical tangent. That gets a little bit trickier where you have to do L'Hopital's rule. I remember doing L'Hopital's rule in Cap 1, perhaps. You might have 0 over 0, but we're not going to worry about that right now. Okay, 55 star, r equals 2 sine theta. Your 55 was 2 cosine theta at theta equals pi over 3. So it should be very similar. Okay, so first I figure out dr d theta. That's easy. The derivative of this is 2 cosine theta. So dy dx is, so by formula, dr d theta goes here and here. So see this 2 cosine theta? It goes here and here. And then by formula, sine theta, cosine theta, sine theta, cosine theta, that's always there. And then it's a plus and a minus. Okay, again, if you want to know where this formula comes from, it's by implicit differentiation of dy d theta divided by dx d theta. Okay, so plus r cosine theta, r sine theta. So r is just the original. So 2 sine theta, that goes right there and also right there. And then by formula, cosine theta, sine theta. Okay, so for these kind of problems, there's always going to be sine theta, cosine theta, cosine theta, sine theta. Sine theta, cosine theta, cosine theta, sine theta. These two right here are dr d theta. These two are the original r. All right, so we look at the numerator. That's the same as that. So 4 sine theta cosine theta over 2 cosine squared minus 2 sine squared, factor out the 2. So I have 2 sine theta cosine theta over cosine squared theta minus sine squared theta. This happens to be the formula for the sine of 2 theta. This happens to be the formula for cosine 2 theta. So the best way to write the final answer is tangent 2 theta. So dy dx is tangent 2 theta. Now they tell me at pi over 6. So I just put in pi over 6. So dy dx is tangent of 2 pi over 6, which is pi over 3. Tangent is sine over cosine. So sine of pi over 3 divided by cosine pi over 3. Radical 3 over 2 divided by a half. On my unit circle, I can draw my 60-degree angle. And I see the x-coordinate looks like it's halfway across. So 1/2 is always paired with radical 3 over 2. So the final answer is radical 3. Okay, so 60 degrees cosine's a half, x coordinate, y coordinate, radical 3 over 2. Okay, 57, which is in the sine problem, r equals 1 over theta. Theta is pi. All right, so call this theta to negative 1. So dr d theta is negative theta to negative 2, or negative 1 over theta squared. Okay, so this is dr d theta. Here's r. So if you look at the original formula, dr d theta goes here and here. So that negative 1 over theta squared is right there and right there. Then it's sine theta, cosine theta. It's always like that. Plus, minus, plus, minus. Plus, minus. Then r. Just copy the original. 1 over theta. So 1 over theta, 1 over theta. And then it always goes cosine theta, sine theta. So there we go. Okay. Now I plug in pi. So put a pi there, but sine of pi is 0, so that cancels out. 1 over pi. Cosine of pi is negative 1. Negative 1 over pi squared. Cosine of theta, cosine of pi is negative 1. Minus 1 over pi. Sine of pi is 0. Okay, so that's gone, that's gone. I got negative 1 over pi over positive 1 over pi squared. And if you divide by a fraction, you multiply by the reciprocal. So negative 1 over pi times pi squared over 1. So the final answer is negative pi. All right, so that's that. And then 61, I'll show you 61, and then maybe that's about it. 61, r equals 3 cosine theta, horizontal or vertical tangent. So let me show you how to do one of those. Okay, so I need dr d theta, negative 3 sine theta. So dy dx, dr d theta, top and bottom. Copy that here and here. Sine theta, cosine theta. Plus, minus. You just template, just copy it. R, 3 cosine theta. So 3 cosine theta, 3 cosine theta. And the top has cosine, bottom sine, cosine, sine. Okay, so this factor out to 3, I get cosine squared minus sine squared. And the bottom, I got negative 3 sine, cosine, and another negative 3 cosine, sine. So negative 6 sine theta, cosine theta. And after canceling, cosine squared theta minus sine squared theta divided by negative 2 sine theta, cosine theta. Okay. All right, horizontal tangent. Horizontal tangent, dy dx. Oh, sorry, the numerator, dy d theta is 0. So set the numerator equal to 0. Cosine squared minus sine squared equals 0. That means cosine squared equals sine squared. Okay. That happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, on a unit circle. Cosine and sine are either the same or they're opposites. Well, that's there, 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 and there. Label the order of pairs. This is a little bit tricky. Okay, the way you write it is always r theta, not theta r. So even though r is a function of theta, you don't write the pi over 4 first, you write the pi over 4 second. So I'm going pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. If you're wondering about the cross off, that is correct. I'll talk about that in just a second. Okay, so plug in pi over 4. Cosine of pi over 4 is radical 2 over 2. So I have 3 radical 2 over 2. Okay, 3 pi over 4, cosine is negative. So negative 3 radical 2 over 2. 5 pi over 4, cosine is negative. Negative 3 radical 2 over 2. 7 pi over 4, cosine is positive. So once again, 3 radical 2 over 2. So superficially, it looks like I have 4 points. 3 radical 2 over 2, negative, negative, positive, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. However, I'm crossing this out because if you look carefully, these two represent the same point. They're 180 degrees apart from each other, pi over 4, 5 pi over 4, and they're opposites. So they don't really represent different points. They're the same point. Okay? So you should only list it once. Which one do we prefer to list? Then one with a positive r. So I cross this one out. And likewise, these two represent the same point. 3 pi over 4 and 7 pi over 4 are 180 degrees apart from each other, or pi radians. So here you aim at 7 pi over 4 and you walk out a positive quantity. Here you aim at 3 pi over 4 and you walk backwards the same amount. So you land at the same spot. So once again, cross off the negative r. So we will list our answer only as 3 radical 2 over 2 pi over 4 and 3 radical 2 over 2, 7 pi over 4. Okay, so that's a little bit tricky. Okay, so these represent the same point. No need to write it twice. Okay, vertical tangent. Make the denominator equal to 0. Negative 2 sine theta cosine theta equals 0. Well, that means either sine of theta is 0 or cosine theta is 0, i.e. x is 0 or y is 0. That's here, 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 and here. The quadrantal angles, as it's called. 0, pi over 2, pi, 3 pi over 2. No need to go back to 2 pi. I have duplication. Okay, so I plug in 0. Cosine of 0 is 1, so that gives me 3. 3, 0. Plug in pi over 2. Cosine of pi over 2 is 0. 0 times 3 is 0. 0 pi over 2. Plug in pi. Cosine of pi is negative 1 times 3 is negative 3. Negative 3 pi, and yes, that is a cross off there. And then 3 pi over 2. Cosine of 3 pi over 2 is 0 times 3 is 0. Okay. All right, same game. This mark here. These two both represent the pole origin. 0 comma pi over 2, 0 comma 3 pi over 2. That's the same thing. It's the pole. In fact, for the pole, you can write in general 0 comma, it is 0, 0, but it's actually 0 comma any angle that you want. Think of a beacon of light, like on a lighthouse, okay? It turns like that. So you change the angle, but you're still here. You're not changing your location. I could swing like that and swing all the way around. Okay, I am changing the angle, but I'm not going out anywhere. I'm not stepping out. So the R stays 0. So for the pole, R is 0, theta is any angle that you want. So 0 pi over 2 is the pole, 0, 3 pi over 2 is the pole, 0 comma 316 degrees is the pole. And once again, notice these two, 3, 0, and negative 3 pi are the same point. 1, 2, 3. In polar coordinates, 3, 0 means I aim at 0 degrees or radians, and I walk out 3 units. Negative 3 pi, I go to 180 degrees. Okay, I'm ready to walk this way. And then I see, oh, a negative 3. So I walk backwards, 1, 2, 3. I land at the same spot. So you should not put both of these. Okay, so we never saw that in X and Y. It only shows up in polar coordinates. So likewise here, you should not put both answers. You should cross off any duplicates. Which one do we cross off? Generally cross off the negative. So we're going to keep 3, 0 and throw out negative 3 pi. Okay, so I'm going to present my answer as 3, 0 in polar coordinates and the pole. Right, you don't actually have to write that P there, but it is ambiguous. Although I'm just thinking in this particular case, 3, 0 in rectangular coordinates also land you in the same spot, coincidentally. In regular X and Y, you would still call that 3, 0, right? But in polar coordinates, it's also 3, 0 because the angle is 0 and you work out 3. Okay. All right, that is that. I'm actually done with the section. Okay, so give you a heads up for 10.4 where we're headed. And how much time do I have left? Very little. If I have time, I'll set you up a little bit more for the quiz tomorrow. But starting 10.4, we have areas and lengths in polar coordinates. Okay. We're going to focus on areas. We're not going to do much about length. Here's a formula you need on your cheat sheet. Area is integral from a to b of 1/2 r squared d theta. Okay. Theta is going between two angles. Okay. Just a little bit of analysis. We had the formula for the area of a sector from Trig. Okay. Sector of a circle, like a piece of pie. You cut out a piece of pie, piece of cake, right? Like so. Area formula was 1/2 r squared theta, provided data was in radians. Okay, you can look it up or not, you don't really have to. What we're doing now is trying to find the area of this weird thing. R is a function of theta, and we're going between two angles, alpha and beta. So it's like angle 1 and angle 2. So before, when we were integrating on the x-axis, we're going from A to B, like from here to here, right? But here, we're going between two angles. So before, when we were doing our Riemann sums, okay, we would chop, right, and get a delta x. We'd be going like this, right, and get a whole bunch of rectangles. Now we're chopping like so. We're starting at the origin of the pole, and my slices are going to be thin delta theta. It's a little change in theta, and like that, 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 right? So here's a typical slice, and we are saying this tiny little slice looks like this. And you might say, well, it doesn't really look like it. That's true, but the usual game, if delta theta is very small, they slice thinner, so the slices are going like this. Right? And then you get closer and closer and closer in. Okay, so we slice very, very thinly. It looks more and more like this. Where delta A is approximately 1/2 f of theta sub I squared. That's r squared delta theta. Okay. Just like before when we were slicing this away, right? We said, okay, they're very close to being rectangles for continuous functions. So likewise here for continuous functions, the picture looks more and more like this. And so we end up taking the limit. And so it ends up being this. Okay. Now, whether you understood that analysis or not, this is what you want for your cheat sheet. So how do you find areas? Integral from A to B of 1/2 r squared d theta. Okay. That's the main formula. Let me show you the problems. So 10.4, what did we have? We had to go all the way up to 41. There is something called a 31 star. I'll have to talk about 31 star. I'm going to write in my book right now. I'll write it directly in my book. Okay, so homework problems, page 672. 5, 7, finding areas. Okay, 31 star is what I have in the book. Instead of r equals sine 2 theta, r equals cosine 2 theta, I'm just making it sine theta, cosine theta. Okay. Which means if you look up the answer in the back of the book, it'll be different. So don't look in the back of the book. It's like an even problem. Okay. And here's that. And we'll go how high? Problem 41. Find the points of intersection of given curves. There we are. Okay. All right. So that will do it. Time is just about up. But I noticed I didn't get the 40-minute time limit, so I think we're okay. Let me just give you a quick heads up as to what's happening. We can prepare for the quiz tomorrow. We have a 4 theta involved. So take one of these things. So I'm starting you up with a little bit of it. Here's 0. Here's 45 degrees. 5 or 4. Okay, now the one I already did in class, there was a 2 theta. So we had to go halfway between these three, 1, 2, 3. So that's maybe like there. (22.5 degrees). And half of pi over 4 is pi over 8. So for 4 theta, you got to cut each of these in half. Okay. Now this is where these lines kind of get in the way. Okay. Can you pretend that these other lines aren't in the way? It kind of makes it easier to analyze it. Okay. So now I got to cut this angle in half. So I somehow have to mentally block out that there's all these other lines in the way. Just focus on these two here. If I only look at those, then maybe halfway is like that. And these two here, halfway, just eyeballing it. Don't even look at all the other lines. Maybe it's like that. Okay. So I'm going to have to go like so. And like so. So I've divided the 45 degrees into 4. So this is 11.25 degrees, pi over 16. 2 pi over 16, 3 pi over 16. And then this one, I don't even know what that would be. 33.75 degrees. You don't have to write the degrees. It's actually easier to write it in readings, in my opinion. Okay. So you'll be counting by pi over 16s, and you're going to have 4 times the original for my chart. So you should have 4 charts, 1, 2, 3, 4. So pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16, and keep doing that all the way around the circle. Okay. So you can either wait until tomorrow to do it when I give you what the actual question is, or if you want to save time, take one of your polar graph papers and start doing this all the way around. So you're going to have what, 5 pi over 16, 6 pi over 16, 7 pi over 16, 8 pi over 16, which is the same as pi over 2, and go all the way around. Okay, so that's what you're up against for tomorrow's quiz. So you will definitely need this for the quiz, because I'm going to give you a 4 theta one, which was again similar to problem, what was it again? In the text, similar to 37. Okay, so I'm not giving you 37, but a variation of it. Okay, where there's a 4 theta there. Okay. All right, we're just about out of time. Let me stop the share. Any quick questions? All right, have a good day, and we'll see you next time. All right, bye, everybody.
Thank you.